Hi everyone, welcome to the .NET 6 Microservice series. Okay, this is the part 3 video of this series. So in this video, we are going to create a microservice application for orders endpoint. Okay, in the second previous video, we have created a microservice application for products endpoint. So this is the second microservice. In this microservice, we are going to create the orders endpoint. Okay. So here we can see the flow of our demo of our .NET microservices. Okay. So here you can see highlighted box. So I am going to create the orders API in another microservice application. And this orders API has its own database, something like sales business database. Okay. So let's jump into creating the .NET 6 Web API application, which will be our microservice application. So here is the .NET CLI command for creating the API project, and I am naming my project name as salesbusiness.api. Okay, let's create the project. Okay, project has been successfully created. Let me open my project in Visual Studio Code Editor. Okay, here is our Web API project, and target framework is .NET 6.0. Let's first install required Nuget package like EF Core and EF Core SQL packages. Now, the package we need to install is Microsoft.NT Framework Core package. So copy the package, install it. And the next package we need to install is Microsoft.NT Framework Core.SQL Server. Okay, copy the package, install it. And we know that our microservice that contains order API going to consume sales database, right? So let's go to SQL Management Studio. So here you can see sales database that contains orders table. Okay. Now let's create a class for this orders table into our application so that I can interact with the SQL Server table using the NT framework code. Now let's create a folder like data. Inside of it, let's create another folder like entities. And now let's add our table class, that is orders.cs. So into this orders class, let's add the properties that are equivalent to the names of the table columns. Okay, so our order class look like this, and here we need to observe one thing, that is product ID. Product ID is nothing but, if you recall our previous video, we have created the product endpoint, right? So that API consumes products table. So the same ID we are going to save with the orders table. Okay, and here we can observe there is no product information like product name like that, right? So how to get that product name into this microservice application, we are going to do it in the next video using the RabbitMQ message broker. Okay, until then, just keep in mind we are just going to save the product ID into our orders endpoint. Okay, so now let's create the database context. Okay, so inside of the data folder, let's add a class like. Okay, okay, now it is just a plain .NET class. To make it database context class, we need to inherit DB context that loads from the NT framework core. Okay, now let's create the constructor and pass some database options. Okay, and type will be our context class itself. Okay, and now we have to register our table classes into our database context so that we can interact with our SQL tables. Okay, to register the table classes, we have to use the DB set. Inside of the DB set, we have to define the type as our table class name. Okay, okay, that is our DB context. Now let's add the connection string in the app setting.development.json file. Go to app settings.development.json file and let's create a connection string and give them property name like okay. Here add your database connection string. So after adding connection string, let's register our database context into the program.cs file. So builder.services.add db context, and here we have to specify the type of our context class. Okay. And here we need to define our connection string. To do that, builder.configurations.get connection string. To this connection string, we have to pass our connection string property. Okay. Okay. Now let's create a endpoint for orders. So let's add the controller like orders controller. Go to controllers and create like orders controller. Okay, this is our order controller. Now let's inject our database context into the constructor of the controller. Okay. In general, microservice is itself a very small application where we are going to contain just basic CRUD operation like create, read, update, and delete operation. Okay. To make our demo short and sweet, I'm going to implement only two operations, that is create operation and the read operation. First, let me implement the create operation so that we can save some data into the database. Okay. So let's implement the create action method here. Okay, this is my post action method. Since it is only single post action method, no need to specify the route explicitly. Endpoint can recognize the post endpoint action method, and it should be decorated with the HTTP post method verb. Okay, and now we have the orders as the input for this action method. So what I will do, I'm going to call context orders.add a new orders, and we are going to call save changes async for saving the data. Okay. Now, if you want, you can directly return the newly created object with the OK method. But it is recommended way is along with the newly created record, we have to return some URL. So that URL should be identify the record newly created. Okay. So the UI can use that URL for getting the details of the particular item. So that means we need to create a get action method by ID. Okay. So first let's create a one get action method. So this is my get action method. It should be decorated with HTTP get, and I have to specify route explicitly because I need to pass the ID value. Not only that, I'm going to create a one more get async method where that method returns all the data from the database. So for this method, I am going to explicitly specify the route. So here is the dynamic route value. I am giving ID. So whatever value will be in the route will be read by the action method. Okay. So now where order equal to find async, and I can pass ID directly. And we can simply return the item with OK method. Okay. So we are done with the action method. Now let's go to our create action method and let's return the response. So here we are going to use the create at action Okay. So for this, we need to pass the get method name. So it's going to generate a URL for us. Okay. Filter by ID. This action method URL will be generated by this created action. And here we have to specify the any routes we have. So we have dynamic value ID, right? So we have to specify as the second parameter, and third parameter will be the entire newly created record. So what it will do means it will return the newly created record as a response, and it will generate the get endpoint by filter ID as a in the response as a header, so that UI applications can use that URL for binding, so that users can view the details of the newly created item. Okay, I have to specify dot id. Okay, I will insert record again. Okay, so let's add some random value as a user ID and the product ID. Copy it. Okay, and now try to create order. Okay, now order is created, and you can see the URL is generated. So if I copy this and open, I need to fetch the item details. See. Okay, so that's how create operation will work. And next we are going to write another get action method that's going to return all our orders as a response. So what I will do, I will create another get action method. Okay, this is my another get action method. It should be decorated with the HTTP get. Okay, and I want to return all my orders. So I can use to list a sync. Okay, and I simply return OK. Okay, that is our get endpoint for returning all our data. And here small correction, it should be awaited. Okay, now run on test our endpoint. Okay, here is our orders endpoint. Okay, let's execute it. And here you can see our data is came. But here you can observe our order is fine, but we don't know what is the product, like product name, something like that, right? So we don't have product information in our uh, sales business database order table. Okay, how to achieve that? Okay, so that will be explained in the next video. Okay, for that we are going to use the RabbitMQ message broker for sharing the asynchronous data between the two microservices. Okay, so from this diagram you can see, right, we have completed the orders API, and previous video we have completed the products API, and I have mentioned, right, in the next video we are going to share the data between products endpoint and orders endpoint using the RabbitMQ message broker. Okay, we are going to implement that in the next video. I hope this video has delivered some useful information to you all. If you like my video, please do support me by subscribing to my channel. Soon we are going to meet with new videos. Until then, signing off.